Well, hello there. All right, so today we're doing, I'm going to skip 9.2 and do it tomorrow. Just seems to make more sense to do this one first. So we're going to graph and write equations of circles. That's 9.3. So what I want you to do is find the distance between the given point, 0, 0, and the given point. So you're going to kind of use the distance formula if you remember from yesterday here. So do that for these two, and then identify the slope of the line perpendicular. It shouldn't take you too long to do this warm up, so take a second to do it. All right, hopefully this is what you got. You found this to be 5, and remember distance is always positive, so we don't use the negative square root. This is 13. Negative reciprocal, opposite reciprocal, -3, and 1/4 here. All right, so what information do you need to write the equation of a circle with the center at the origin, 0, 0? Let's look at some of this vocab. A circle is the set of all points x, y in a plane, because we're going to look at circles on coordinate planes today, that are of distance r from a fixed point called the center. So basically what they're saying is you have a center, and what a circle is it's any point here that is, all of these points are the same distance from the center. No matter where you go on the circle, they're all going to be the same distance from the center, and we call that r, the radius basically. It's the distance from the center of a circle to a point on the circle. Here's a standard equation of a circle with the center at the origin. And we're going to be able to use this today to find out what the radius is and all kinds of fun stuff. All right, so let's try some of it. So this is, remember, this is what you're using. X squared plus y squared, this is a point, and that's going to be the distance of the radius, the length of the radius. Graph the equation and identify the radius of the circle. So you may look at this and say, what? But if you write the equation right above it, x squared plus y squared equals r squared, we can figure out what r is just from using this equation. If you see right here, r squared is equal to 9. Take the square root, and your radius is 3. So on the graph, remember all the circles we're working with today, the center is at the origin, so we just go over 3. You can use the y-axis up 3, over here, and that kind of gives you the structure of your circle, and then you just connect them as a circle, which this one isn't that great. It's kind of hard to make a good circle sometimes. And that's this right here. The radius is equal to 3. Pretty easy. All right, and let's try this one. Now it's not quite in the right form, so I need to get it in this form. X squared plus y squared equals r squared. So that just means I have to move the y over, because I want to make it positive, just as easier to work with, and then I'm going to move the 18 over. So when I do that, it looks like this. Move the 18, move the y. And now it's in this form. So this tells me that r squared equals 18. So I just have to take the square root of both sides. Oh, but look, this is one that we can simplify. Remember, 18 can be split up to the square root of 9 times the square root of 2. And I'm going to write it like this. The radius is the radius is 3 times the square root of 2. Now to help you draw it on here, you might want to just go to your calculator and get the decimal version of it. It's about 4.24. If you didn't have a calculator, you could just think about the number 18 and think about the perfect squares closest to 18, which would be 16 and 25. That means that the square root of 18 is between 4 and 5, which are the square roots of 16 and 25. Number sense. You can do it. All right, so remember all the circles we're working with, the center's at the origin, and that means the radius is 1, 2, 3, 4, just above 4 here, all the way around. And you just connect them to make your circle. And the radius equals 4.2, oh, excuse me, let's write it like this. The radius equals 3 times the square root of 2. It's more precise. All right, let's look at one more example using that equation. So this isn't quite in the right form either, so I'm going to add 15y squared to both sides, and I get this. Okay, now if I look at that, I can get rid of a 15. Everything can be divided by 15. And then I will have what I'm looking for. All right, and then I can just say, all right, that means that r squared is equal to 4, and r would be 2. So what looked like a complicated problem turned out to be a pretty basic problem. And then you just connect them, and r is equal to 2. So that's one thing you're going to have to practice, is working with x squared plus y squared equals r squared. All right, let's turn it over. All right, now, this one's a little bit different, but it's still working with that equation. X squared plus y squared equals r squared. It says write the standard form of the equation of the circle for the given radius with the center at the origin. When they say this, that means you're working with this. All right? So they're giving me the radius, so I'm just going to plug it into my equation. Square root of 3 squared, because this is the radius. It's not squared, so I got to square it. And then I got to make it pretty. Can't just leave it like that. Remember what this means? This means the square root of 3 times the square root of 3. Or you could just remember that square and square root cancel each other out, and you're left with what's inside there. So you would put a 3 here. Now you may think that might look a little funny, but this is my radius squared, because this was my radius. When it's squared, it's 3. So that's the right form. Okay? All right, here, they gave me the radius of 7. So I'm going to write this, x squared plus y squared equals 7 squared. That one's pretty easy. I'm going to write it correctly here, and I'm going to write it as 49. And that's the standard form of the equation. All right, let's do this last one here. This is my radius. So I'm going to write x squared plus y squared equals 3 times the square root of 5 squared. So if you remember, this means 3 times the square root of 5 times 3 times the square root of 5. It's all multiply. So you can just multiply the numbers together. 3 times 3, which is 9. And the square root of 5 times the square root of 5 is 5. So I'm going to write my equation as x squared plus y squared equals 45. This is r squared. It's that squared. All right, so that's another thing you're going to have to do. All right, here's a third way you're going to have to look at it. Write the standard form of the equation of the circle that passes through the given point, and the center is the origin. When they say that, I know that I'm going to work again with this equation. So notice in this equation there's an x, a y, and obviously an r. Well, if they're giving me a point, they're giving me the x and the y. So I'm just going to plug it into the equation. Negative 4 squared plus y, 7 squared equals r squared. To write the equation, I ultimately need r squared. That's what I'm going to go for here. All right, so if I square negative 4, I get 16, and then 49 equals r squared. Add these together. My r squared is 65. Now I can write my equation. X squared plus y squared equals 65. That is my r squared. Same one here. X and y, just plug it in. 5 squared plus negative 1 squared equals r squared. I need that value. So 25 plus 1 equals r squared. 26 equals r squared. Once I have r squared, I can write my equation. X squared plus y squared equals 26. Boom. All right. I don't know if you guys talked about tangent last year or not. It might be something new. It's not that difficult though. It's a word you'll definitely hear in pre-calc and calc. Write the equation of the line tangent to the circle at the given point. Tangent means perpendicular to the radius. Okay, so they gave me the equation of the line here, or excuse me, they gave me the equation of the circle at 6, 1. So what I want to do is I'm going to just automatically plot this point over 6, up 1. Make a note to myself that that's 6, 1. Okay. What they're telling me here is that this point is on the circle. Therefore, from the origin to here is the radius. That's the radius of this circle. So I am going to, it's over 6 all the way around, so I'm just going to kind of make my circle. It's up 6 here, over 6, down 6. Lovely circle. My goal is to write the equation of a line that's tangent to this circle at this point. So tangent means perpendicular to the radius. So I'm going to kind of just sketch it here. Perpendicular to the radius. I want the equation of this tangent line. All right? So I know that I can write equation with the slope and the point. And I'm guessing that I already have a point because they said it's going to go through this point right here. So I already have a point, which is 6, 1. So the first thing I'm going to think about is the slope of this radius. If I know the slope of this line right here, I know that the slope of this line is the inverse of it, the opposite inverse, okay? So the slope of this line is up 1 over 6. The slope of my original line, or my radius, is 1/6. Up 1 over 6. Therefore, I know that the slope of the tangent line is going to be the opposite reciprocal or negative of that. Flip it, make it negative. So that means the perpendicular slope is -6. All right, so I have the slope of that line. That's what I need. I also have a point on my tangent line. Which is 6, 1. So I can write the equation of my tangent line by using point-slope form. I'm going to go y minus 1 equals my slope, -6, times x minus 6. And then I'm just going to convert that to y equals mx plus b. Y minus 1 equals -6x plus 36. And if I move it around so y is by itself, I'm going to add 1 to both sides, and I get the slope, or the equation of the tangent line, which is -6x plus 37. So the steps would be, plot this point. It says that point is on my given circle, so it's from the origin to here. You find the slope of your radius. Just count 1 up over 6. So the slope is 1/6. The tangent line is perpendicular to that line. So the slope of the tangent line, you flip the slope and make it opposite, which would be -6. The tangent line is also on this point. So there's a point on that line. And then you just plug it into point slope. Okay, last one here. A business owner wants to buy property within a 30-mile radius of the airport. Okay, I'm going to stop right there and draw that picture. I'm going to draw a coordinate plane. I'm going to say right here, this is my airport in the center. 30-mile radius. Okay, so I'm just going to kind of make a circle Try and make it sort of equal. It's a little bit of a bad circle, sorry. So this is 30 miles, this is 30 miles, this is 30 miles, and this is 30 miles. A business owner wants to buy property within this area here. She finds a property 10 miles west and 24 miles south of the airport. Well, if we think of this as a map, this is east, north, west, and south. So 10 miles west, 24 miles south at this point, about. Okay, so she finds a property 10 miles west and 24 miles south of the airport. Is the property within 30-mile radius of the airport? I think these are kind of weird problems because it's pretty obvious, but what they really want us to know is if this distance from here to here is 30 miles. Well, I can test it, okay? The property is at -10, 24. That's an X and a Y. I got to prove it though. Prove that it's within that 30-mile radius. So I can use this equation right here. X squared plus Y squared. I want this distance to be less than my radius squared. So let's just plug in the points and see. -10 squared plus 24 squared. Is it less than my radius squared? 100 plus 576. And remember my radius, which was 30, is 900. 30 squared is 900. Add these together. 676 is less than 900. So yes, it is within 30 miles of the airport. So basically this whole section is about using the standard equation of a circle. Oh, and you also got to learn about tangent. Alrighty, that's it, folks.